So we'll start with number one, where we have two forces with magnitudes F1 and F2 act on an object at right angles to each other. And they just want to know what is the magnitude of the resultant force. So this is just simply using, you're probably familiar with the triangle rule. So if you have two forces, F1 and F2, they're both at right angles, then we know that the third side will give you the resultant like that. And using Pythagoras, we can find out what the resultant is. So if we want this side, we know that we would have to square this one and square this one. So F1 squared plus F2 squared would be equal to the square of the resultant. And then if we take the square root of the resultant, that will give us the square root of F1 squared plus F2 squared. So that shouldn't be too difficult. So that will be 8. The next one is a boy takes 30 minutes to cycle a distance of 8 kilometers. He then walks a further distance of 2 kilometers in 15 minutes. So what's the average speed? Now, one thing that you always need to be careful about, Doris is saying she is having trouble hearing me. Jana, can you hear me?
Yes, I do. I can hear you.
Um,
I think there is a problem with her voice or microphone. Yeah. Can I ask you a quick question in question
yeah,
one?
of course. And just to clarify, the point here is not for me to just, do questions and keep going. If you have any questions, you're welcome to just ask in between whenever you want.
Okay, thank you. And now, if they asked us on a question that they're not at right angles, what could the possible answer be? Or what would they ask?
Did you say that if the two forces are not at right angles?
Yeah.
So usually what happens is that, for instance, if you have something like this, just to give you an example, if let's say we've got a horizontal force going like that, and then another one going like this, then in that case, if we want to use trigonometry, the formula would be more complicated, but they would not ask you to do the math on it.
Oh, okay.
Usually
It's
that
not
would be
required.
on paper 4, where they would ask you to draw the diagram and then do a graphical solution of it, where you would measure the length of the resultant and then find out the value of the resultant from that.
Yeah, so a scale diagram.
Yeah, exactly.
Yeah.
And
Okay.
so if that does happen to be on the MCQ portion as well, then yeah, again, they would give you diagrams where they would ask you which of these is showing the correct setup.
Oh, okay. Thank you.
Yeah. All right. Now for number 2, one of the things that you should always look at when you're doing physics questions, whether it's P2 or P4, it is obviously keep an eye on the units, because that's a very common mistake. And we've underlined, we can see that time is given in minutes, but when you look at the answer choices, all of the times are in hours. So that means the first thing we want to keep in mind is that we need to go with hours. And then again, this should be a straightforward problem. The average speed would just be the total distance over the total time. Total distance is 8 plus 2, so that's 10 kilometers. And then the total time is 30 minutes and then 45 minutes, which is, 15. So a total of 45 minutes. Now, if we convert that into hours, that would be 45 over 60, which is 0.75 hours. So 10 over 0.75 hours. And that will give us about 13 kilometers an hour. And when you're doing the math, this is actually a really good idea, because it helps you avoid mistakes with units. So for example, I know mostly people would just do that, but the problem with this one is that it doesn't indicate the units, so you might miss those out. If you write the unit with the quantity, and let's say if you were going with minutes and you didn't realize that you had to convert, you would write this. And as soon as you write this, it should be clear that your answer is going to be in kilometers per minute, which doesn't match the units given. So you see, it helps you identify mistakes during your working. Then number 3, a small light ball is dropped from the top of a tall building. Which graph shows how the speed of the ball changes with time? Now, there is significance of this phrase, the top of a tall building. So when we're talking about dynamics or free-falling bodies, do you know why they say top of a tall building? Like, what is that supposed to indicate to us?
That it accelerates downwards,
Yeah, that's right. But what
which
if
is
they had said it's falling
decelerating.
from the table?
What?
What if they had said that it was falling off a table?
Um, isn't it the same?
Actually, there is a difference. When they say that it's falling from the top of a tall building or any tall structure, the idea is that in those cases, air resistance has a significant role to play. So this cannot be ignored. If they say that it's falling from the top of a table, just a couple meters high, let's say there's a ball that drops down onto the ground here, then in that case, we usually ignore air resistance because the object does not have enough time to travel through the air. That is the difference. That means in this case, you cannot ignore air resistance because the air resistance has enough time to build up. Now, when air resistance does have time to build up, we know mainly there are just a couple of important stages. In the first stage, it initially falls at an acceleration that is equal to the value of g. That means initial acceleration would be 9.8. And then the acceleration decreases as the air resistance builds up. And then eventually, when the weight equals the air resistance, at that point, the acceleration is 0. So which of these three is showing all three of those phases? Which one do you think it is? A is clearly out because it's showing uniform acceleration all the way. Then D is actually also out because it's showing.
Is it C?
Yes, it is C.
Because of the constant acceleration that occurs? I mean, how speed becomes constant?
Yes. So you see, initially it falls at some uniform acceleration, which is 9.81. And then throughout this phase, the one that I've highlighted, the acceleration is decreasing. And it's decreasing because the air resistance goes up with speed and then eventually becomes 0. So that's fine. Now, if they had said that it's falling from a table, it would have been A. Because in that case, we would ignore air resistance. And the reason is that it falls down so quickly in just under a second that air resistance simply wouldn't have time to build up. So that's why that phrase is important. Number 4 says, which statement about gravitational field strength is not correct? Now, again, another good idea is to underline important keywords in the question. They're really helpful. They help you focus on what's important and really do questions quicker as well. So which one is not correct? In other words, which of these is wrong? Which one would you pick?
D.
D?
Yeah.
Okay, so that means you've eliminated C. This is correct. It is measured in Newton per kg. Then it is equivalent to acceleration of free fall. That's also correct. So we're going to eliminate that. By the way, the acceleration of free fall always has the same magnitude as the value of g, local value of g. In simple words, what that means is that if you're on a planet where the value of the gravitational field strength is 3.6, it would mean that the acceleration of free fall on that planet would also be 3.6 meter per second squared. And this is saying its magnitude is different on other planets in our solar system. That is actually correct. The value of G on different planets is not the same. This one is incorrect because the value of the gravitational field strength does not affect the mass. It only affects the gravitational force that would act on the mass, but the mass of an object is just going to remain what it is.
Isn't way, which is equal to mass times the gravitational field strength, and doesn't like mass doesn't change? I mean, way doesn't change.
So this basically tells you that if you know the mass of any object and the value of G at your location, you can multiply M and G to calculate the weight. If this value changes, yes, the weight will get affected, but not the mass. So the value of G affects the weight, not the mass, because the weight is what is dependent on the gravitational field strength. So if you take, let's say you have a ball and you're here on Earth, and then you just move the same ball over to Mars, the mass is still going to be the same, but the weight is going to change because the value of G on Mars is different from the value of G on Earth. So keep that in mind. The mass does not depend on the location, and then also does not depend on the value of G. It's the weight that depends on the value of G. So in 5, we've got 3 liquids, P, Q, and R, have different densities, and they do not mix. The liquids are placed in a measuring cylinder and allowed to settle, and a small block is then dropped into the measuring cylinder and comes to rest. And it's coming to rest somewhere here. Which statement about the density of the block is correct? So what do you think about number 5? Let's go one by one. It is equal to the density of Q. Is that right or wrong?
Wrong.
Yes,
Doesn't it
that's
change? Yeah.
okay. And then it is greater than the density of P. Is that right or wrong?
So
It's
density of the
it's
water?
settling in P. So if it's kind of floating there, what is that telling us? That the density, if it were greater than the density of P, then the block would have gone all the way down. It would have sunk. But because it's not sinking, B is not true. What about C? It is greater than the density of R. Is it greater than the density of R? R is this one. And the block does not settle here. It goes lower. It doesn't settle here. It then settles somewhere here. So yes, it is greater than the density of R. And that is exactly why it's sinking. It's going all the way through the first liquid R and then comes down and settles here because the density is greater than R. If the density had been less than R, it would have just floated somewhere here. Number 6, we have a uniform beam pivoted at the center, and a student applies 2 forces, F1 and F2. Which row is correct? They want the clockwise moment about the pivot and the anti-clockwise moment about the pivot. Now, when you're doing moment problems related to moments, again, a good idea is to quickly mark the directions of the moment of each force. if we see the pivot is here, now F2 will have a moment like that. That means it's a clockwise moment, so we can just draw an arrow like that. F1 will have an anti-clockwise moment, so we can do that. So then you see now we know which one should go where. So for the clockwise moment, it's the force times how far it is from the pivot. So that's F2 times D4. This one's, so that means A is out and B is out. So the clockwise moment is going to be F2 D4. And then the anti-clockwise moment is the applied force, which is F1. And how far is it from the pivot? That is D3. That means anti-clockwise is going to be F1 D3. So this is the answer. Now, another important thing to remember is that when you're doing F into D, D is always the perpendicular distance of the force from the pivot. So it means we are always interested in how far the force is from the pivot. How far the two forces are from each other or how far they are from the end is irrelevant. So this is not relevant, D2 not relevant. They've just shown those so that they can act as distractors. But those distances are not important. The only thing that matters in moments is how far is the force from the pivot. And the perpendicular distance means that whenever you look at the line that you draw for F, so for example, for F2 here, and the line that you draw for D, they're both going to be at right angles. So you see there's a 90-degree angle here, and there's a 90-degree angle here as well. That's what we mean by perpendicular distance. Just to give you an example, if F were acting at an angle like this, and you were to mark the distance like this, that clearly would not be the perpendicular distance. Because you can see the angle between F and D would not be 90 degrees in that case. Number 7 is which expression can be used to determine the impulse on a tennis ball? So basically they're just expecting you to recall what the equation is to calculate the impulse. Do you remember what that is? There's an equation which is F is equal to mv minus mu over t. And if you just rearrange that, you get Ft is equal to mv minus mu. The product of F and T, meaning force and time, that is what we call impulse. And the magnitude of impulse, as you can see from this equation, is always equal to the change in momentum. But they just want us to tell them how momentum can be, impulse can be calculated. That can be calculated as force and time. And the unit of impulse is the Newton second. And the unit of momentum is kg meter per second. Both of these units are actually equivalent, this one and this one. So they're basically two different ways of writing the same unit. Okay, and then in 8, it says which row shows the process by which energy in the sun is released, the process by which it's transferred to the earth, and a way in which it is stored once it reaches the earth. So let's look at column 1 first. The process by which energy in the sun is released. Now we know that the sun produces its energy through fusion. So that means A and B are just out directly. It has to be either C or D. And again, in these kind of tables, if you just pick one column, you'd be able to eliminate 2. And whenever you're unsure, especially in qualitative questions, it's a good idea to do that. Process by which it's transferred from the sun to the earth. Do you know what that is?
Is it radiation?
Yes, it comes through radiation. And then the only one we can pick is D. And the method by which it's stored would be biofuel. Now here
B wouldn't be an option because like it's also fusion.
which one?
B, because like the end result, like the method is different, but the process is the same.
Yeah,
Like, yeah, but like if it's one of the options will be in the, forget about it.
yeah, that's right. So you see, these two are matching. So number 9, an object has a mass of 20 kg. It's taken upstairs through a height of 4 meters. What is the increase in the store of gravitational potential energy? Now, in quantitative questions, it's straightforward, but it's also very helpful. If you just mark the symbol of the quantity, so M and this is H, it basically makes it more obvious as to what the equation is going to be. We know it's gravitational potential, so we can just do it directly. That's going to be mg into the change in height, or just the height. So mass is 20, and then times the value of g, and then the height is 4 meters. We can even actually go with 10. If we go with 10, we'd get 800. So 9.8 into 4 into 20, that's 784. And if we just round it to the nearest 10, we would get 780. Number 10, an electrician uses a lifting machine. The lifting machine takes 4.5 seconds to lift the electrician through a vertical height of 3.2. The mass of the electrician is 72 kg, and the energy for the lifting machine is supplied by a 2 kilowatt electric motor. They're saying, what is the efficiency of the lifting machine? Now we know that the efficiency is the output over the input. So those are the two things that we need to note in this case. What is the input? It's coming from the electric machine, from the electric motor. And again, let's just mark the symbols. It will make things easier for us. This is P, that is T, and that is the height H. This is the mass, that's M. Now the energy for the lifting machine is coming from the motor, and the motor has a power of 2 kilowatts. We also know how long it takes, which is 4.5. That means we can calculate the input energy easily. Input energy, E, is just going to be power into time. The power is 2000 watts, and the time it takes is 4.5 seconds. So that is 9,000 joules. That's the input energy. Now, the other quantity we need is what is the output that we were able to produce with this input. And for that, we can see that whatever the machine is trying to do, that is the output. The machine is basically lifting the electrician. Now, we know the height through which the electrician has gone. We know his mass. That means, again, we can easily calculate how much gravitational potential energy he gained during that movement. So that's going to be M into G into H, which is 3.2. So that's the amount of energy that he was able to gain. So that's about 2260 joules. So that's our output. That means our efficiency now is going to be 2260 divided by 9,000. So the efficiency would come out to be about 0.25.
Can you re-explain the second part? I don't understand it. Like the GPE part. How is it like the output?
Okay, so when you're looking at what is the input and what is the output, all you have to do is look at this scenario that they've given and just ask yourself, what are we providing to the process or to the overall system? And what is the system providing us? Now, if I ask you about the input, what would you say is the input to all of this process?
The motor and the
Okay,
time for it
yeah.
to
So
lift.
now, yeah. the motor is providing the input. Now, why are we using that motor? What are we trying to do?
To lift it up.
Exactly. We are trying to lift the person up to a greater height. That means that lifting is exactly our output, because that is the goal that we're trying to achieve. So when the person moves through a height of 3.2 meters, he is going to gain some gravitational potential energy. Whatever amount of potential energy he gains during that movement is going to be what our output energy is. So that's why we've calculated the gravitational potential energy here. Now, it cannot be the other way around. As in, if we look at the movement of the electrician, that of course is not going to be the input. Why? Because the motor is not running because the person is moving up. It's exactly the opposite. The person is moving up because of the motor. That means the motor provides the input, and as an output, the person moves upward.
Okay.
And why are we using gravitational potential? Because the main transition only includes a change in height. So that is the only relevant form of energy that we can calculate. If you try to calculate kinetic energy, you wouldn't be able to, because this person over here is at rest. Original state also at rest. Yeah. And you can apply this to, you can think of it like this, that every system basically, there's some machine or process, right? And there's an input, something that we provide, and then there's an output, something that the process or the machine provides to us. Every input-output problem will have the same structure. Whatever you're giving in or providing is the input, whatever you're getting out of it is the output. In this case, we are providing power or energy through the motor, and as the output, we're getting some vertical movement. And of course, this could also be given as a percentage, just as 25%. Yeah. So number 11 says some altimeters use the change in air pressure to measure height. If the pressure is 100 kilopascal at sea level on a particular day, what will be the pressure at the top of an 830-meter hill? And they've told us what we should use for density. Now, we know that for fluids, for example, in a liquid or a gas, meaning in the air, as you move lower, the pressure will increase. As you move higher, the pressure will decrease. Now, they're saying that the change in pressure is basically being used to calculate the pressure at the top of the hill. So let's just draw a simple diagram. So at P1 is right here. So at sea level, we know it is 100 kilopascal. And then as we go some height to the top of the hill, we go 830 meters above. And some pressure here, we will call that P2. Now, the pressure at P2 is going to be the pressure at sea level, P1, and minus the change in pressure that occurs because of the movement. Now, whenever there's some change in height, we know that the pressure P is given by rho GH. So that means we have to subtract that amount from P1, and that will give us the pressure at P2, meaning the top of the hill. So P1 is 100,000 Pascal minus rho, which is 1.3, and then G into H, it moves up by 830 meters. So that's going to be 89,000. So that's 89,425. And we can just say it's about 89,000 Pascal. And with the prefix K, it will be 89 kilo Pascal. That means
Is
the
this
answer.
an official equation or like from the syllabus, or should we deduce it when doing this?
Yes, it is. So
It,
what
oh,
basically,
can you explain it to me? I never took it.
okay, this equation that are you familiar with this one?
Yeah.
Okay, P is equal to rho GH. Now, if we just slightly change this equation, just by adding two symbols, we can do this. Delta P is equal to rho G into delta H. What this means, delta simply means change in. It means the change in pressure, so change in P, is equal to rho G multiplied by the change in height. Now it's the same equation, but it's a lot more descriptive. What it's telling us is that we can calculate the pressure difference between any two locations if we just know the difference in heights between them. That means in this problem, we know that at sea level and then the top of the hill, distances or the height is 830 meters. If you just plug in density, value of G, and a height of 830, that result that you would get would give you the difference in pressures between those two locations. So if I write out the equation, it will be P2 minus P1, meaning the difference in pressures between those two. Or let's just do P1 minus P2, because P1 is greater. This would be equal to rho G times the change in height. So it's still the same equation. We're not actually changing the equation. It's the same thing.
Yeah, so rho GH, it's the difference in both locations, and P1 minus the P2 uh, would give us the answer.
P1 minus P2 on its own would give you the difference in pressures between the two locations. What we want is the pressure at the second location, which is the top of the hill. That means we want to find out P2. So if we want to find out P2, you move P2 to one side of the equation, you would get P1 minus rho GH, which is exactly what we did. For example, if they had said, what is the difference in pressures between the two locations? Then you would simply write P1 minus P2 is equal to this. Rho is 1.3, G is 9.8, and height, difference in heights is 830. There you go. Whatever the product is of these three numbers, that would give you P1 minus P2. In other words, it would give you the difference in pressures between those two locations. So if they had asked for the pressure difference, the product of these numbers would just be the result. And let's just see what that is. 1.3 into 9.8. Okay, that's 10,574. So I'm just going to write it as 10,600, like round off. 10,600 Pascal. That means the pressure difference between the two locations is 10,600. And this is just, yes, it's the standard equation. We've not introduced a new equation. That's what it actually means, that the difference in heights will directly give you the difference in pressures. And that's why it's a good idea to write the equation like this, because again, it's a lot more descriptive. That's exactly what it's saying, that the difference in pressures is equal to rho G times the difference in the heights between the two locations.
But there are questions that we only use rho GH, so it's fine in both ways, right?
Yeah. You can write it like this as well. So if you write, instead of this, if I just erase this and write rho GH, it's totally fine. So you don't have to write it the other way. It's the same thing. And you're not going to get any penalty for that because they both mean exactly the same thing.
Okay.
So number 12 is saying that water can exist in three states: solid, liquid, ice, solid, liquid, and gas. In which states is the motion of the water particles only vibrational? So which one is it?
C.
Yeah. All right, so now a cube has sides 2 meters long. The cube contains a gas at a pressure of 8,000 Newton per meter squared. And a second cube has sides 4 meters long. So this cube contains the same mass of the same gas. So we've got the same mass of the same gas as the first cube at the same temperature. So the mass is not changing, temperature is not changing. What is the pressure of the gas in the second cube? Now clearly, this is a comparison between the first one and the second one. So if the mass of the gas is not changing, which it says here, then temperature is also not changing. The first thing we need to know is why would the pressure even change? What is the difference in the two cases?
The volume.
Exactly. And the volume here in the first case is just 2 cube, right? So that's 8. And volume here is 4 into 4 into 4, which is basically 4 cubed, that's 64. Now we can see that the volume is going up by a factor of 8. Is that right?
Yeah.
So the second cube has a volume that is 8 times larger. What's the relationship between P and V?
Directly proportional.
So P is actually inversely proportional to the volume.
Oh,
And why
P.
is that?
Oh.
Because if you have a bigger volume, so if you just imagine you have some particles inside, let's say there are 4, they're going to bounce around and hit the walls of the container. And then we have the same 4 particles here as well. Now clearly, because they have a much larger space through which they're going to travel, the collisions with the walls of the container are going to be less frequent. So that means in the same amount of time, they're going to hit the walls on fewer occasions. Now, a fewer number of collisions means that the force exerted is going to be smaller, which basically means that we're going to have a lower pressure as well. So there are 2 ways to do this. We can do it directly. P is inversely proportional to V. Mathematically, what that means is that if any of these quantities increases by a certain factor, the other one will decrease by the same factor. So for example, we know that the volume is going up by a factor of 8, meaning it's getting multiplied by 8. That means the pressure will actually get divided by 8. So the original pressure is 8,000. If you divide that by 8, the new pressure is going to come out to be 1,000. And that's the answer. The other way to do it, if you want to convert it, you can convert this. There's another equation in the syllabus, which is exactly coming from this relationship. P1, V1 is equal to P2, V2. Now let's say this is 1 and this is 2. We know this is P1, this is V1, then we also know V2, but we don't know what the pressure is in the second case. That means we have to find P2. So let's just rearrange the equation. It will be P1, V1 over V2. So P1 is 8,000 into V1, which is 8, divided by V2, which is 64. So that's 1, and that's 8, and that's 1,000. So we get the same result both ways. You can use the equation, but this is just a much quicker way of doing it because that's exactly what it means for 2 quantities to be inversely proportional. If they are directly proportional, let's say if, for example, some quantity A is directly proportional to B, that would mean that if B goes up by a factor of 8, A would also increase by exactly the same factor. If B gets divided by some number, let's say divided by 6, then A would also get divided by 6. In an inverse proportionality, the inverse happens. You see this one increasing by a factor of 8, this one decreasing by a factor of 8. It's a matter of preference. Whether you do it like this or like this, it doesn't matter. So 14, which row gives the correct name for each change of state shown? Which one would it be?
B.
Yeah, that's pretty straightforward. All right. And then 15. In an experiment to measure a specific heat capacity, a block of aluminum is heated and its rise in temperature is measured. The internal energy gained by the block is delta E. The mass of the block is M. The rise in temperature is delta T. You see again, now the delta symbol is coming in because that's what it means, change in energy or change in temperature. Which one gives a specific heat capacity? Now, whenever you're doing something like this, first write out the equation in the form that you are most comfortable with. So for example, if you do delta E is equal to mc times delta T. That's the equation, right? Now, because they want us to tell them which expression gives the specific heat capacity, we should now rearrange and make C the subject of the equation. So don't do it directly. So that's delta E, and in the denominator we would have M times delta T. So whenever you're asked for an equation where, because you see the form in which we usually remember the equation is actually this one, not this one. So if you try to do it directly, you might get it wrong. The safest way to do it is write it in the form that you're most comfortable with and then just simply rearrange it before picking the answer. So which statement about the transfer of thermal energy is correct? Number 16. Now again, just for the sake of understanding so that you're more comfortable dealing with a variety of questions, these types of qualitative questions are trickier than the numerical questions that you get. So one really good idea is to use elimination. So let's just do that for practice. Are there any two choices that you can eliminate with certainty, like with a high level of confidence that those are wrong?
A and D.
Sorry, say that again.
A and D. Oh yeah, A. Yeah.
Okay, A is out. Now, what about B? Convection can only occur in solids or liquids. That statement is correct?
Wrong.
Yeah, so A and B are out. You see now, as soon as you do that, the reason why this method is so helpful is that you now only have to think about two statements. So even if you're a little unsure, your probability of getting it right is way higher. Mathematically, it's actually twice as high. So which of the two is correct?
D.
Yeah, that's right. The radiation is a type of electromagnetic radiation. And, just to help you recall, you should also know the spectrum of the electromagnetic spectrum, actually, and also be able to tell the order in which they're increasing or decreasing. So, for example, when we look at radio waves, those are low frequency waves. And then when you look at all the way at the other end of the spectrum, where we have gamma rays, those are high frequency or high energy waves. Okay, what is the number of wave fronts per second that pass a fixed point? Which quantity does that give us? The number of wave fronts that pass.
Frequency.
Yes, because each time a wavefront passes, basically that's one wave. And then we count the number of waves in a second, that's the frequency. All right, so an earthquake under the ocean can produce a dangerous water wave called a tsunami. The table gives typical data for a tsunami: the ocean depth, velocity, and wavelength. A a student suggests 3 conclusions about the data. Number 1 is saying the deeper the ocean, the faster the wave. Now, looking at the table, can you infer that from the table that the greater the depth, the faster the wave? Is
Yeah.
that something? Yes. And if you look at ocean depth, you go from 2 to 7,000. Velocity going from 504 to 948. All right, so we'll do that. And number 2, the longer the wavelength, the faster the wave. Is that supported by the table?
Yes.
So longer the wavelength, okay, fine. That's also in. Now, the faster the wave, the higher the frequency. Now, if you look at number 3, the faster the wave, we do have information on that right here. The higher the frequency. We don't have direct information about the frequency. Instead, we have the wavelength. If the frequency gets higher, what would happen to the wavelength?
Inversely proportion.
Yeah, so is 3 right? The faster the wave, the higher the frequency?
No.
Yeah, 3 is not right. So it is B. 1 and 2 only. And again, whenever you get a question where there are multiple statements, you should always qualify them one by one so that you can pick which one is correct. Don't look at the choices directly because then you increase the load mentally. Note it down, which one's right, which one's wrong, and then whatever your final result is, go with the choice that matches your information. So here we have wavefronts that are going, they enter a harbor. They're saying, what caused the change in the shape? What is the name of that process or effect, actually?
Diffraction.
Yep, that's also straightforward. Okay. In number 20, what's the angle of incidence and what is the angle of refraction? So what is the angle of incidence?
This A.
Okay, and yeah, let's just mark those. So the angle is always between the incident ray and the normal, and that's going to be 40 degrees. And the other one, we already have the angle between the refracted ray and the normal, that's 25. So yeah, A is correct. And whenever you have questions on rays or light where you're dealing with angles, make sure you're always looking at the normal because the angles that we use are with the normal, not with the boundary. Okay, so 21. An object is placed in front of a converging lens and the lens has focal length f. The lens produces a real enlarged image of the object. In which labeled position is the object placed? Now, in this case, the focal length is f. And there are certain locations where we know what the result is going to be, as in we know wherever we place it, what's going to happen. When we place an object inside the focal length, for example, at D, that produces a virtual image and it's enlarged. And that's the setup that we use for a magnifying glass, actually. So because this is a real image, it means the location cannot be D. And if you place something at 2f, meaning at a distance that's twice the focal length, so for example here, that produces an image of the same size. If you place it at f, there's a different result. So they're saying this one's real and it's enlarged. When it's real and enlarged, it's supposed to be between f and 2f. So that means the location should be B. And actually, if you just do a quick Google search, I can show you if you want, and you do IGCSE physics lenses, you go into the images, you'll see one of the images has a table, and that gives you all the settings that you get. Meaning what happens if you place it at F between 0 and F, or what happens if you place it at 2F to the left of 2F. So all those different locations, we know what kind of result we're going to get. What's the speed of electromagnetic waves in a vacuum?
Three times 10 to the power of 8.
3 into 10 power 8
Uh,
meters per second.
sorry, but what did you search? Because I want to print it out.
Oh, I'll show you, don't worry. I'll
Yeah,
show you. I
thank
didn't
you.
search it, I just remember, but I'll show you.
Yeah.
What is the speed of the electromagnetic wave? 3 to 10 power 8 meters per second. But in meters per second, we only have option A, and that's 300, so that's wrong. So that means we will have to convert this into kilometers per second. So how many kilometers per second would that be? What would the power of 10 be?
Divided by 1,000. So
Yeah.
it's
So
power
3,
5.
yep, kilometers per second. So that's 300,000 kilometers per second. So that's C. Okay, so all right. What we will do, actually, what I was going to do, and I can just tell you now, we will do this again. So it's the 8th. We will meet on the 22nd. And what we'll do is we just have about 18 questions left. We'll finish this, and then we'll actually go on to do paper 4. And I'll tell you what all I'll help you with. So aside from doing the questions, the idea is that you need to really understand how to do this stuff and make you know the concepts behind it. And there are certain important things that you need to know. One very important thing would be the list of command words. You can find those in the syllabus. For example, when they say state or explain or suggest or describe, you know, what's the difference between those? And then another really important thing you need to know is how do the examiners actually use the mark scheme? And then over there, we have these types of marks, A, B, C, and M. So I'll also show you how to use the mark scheme to grade your own attempts so that you can do it accurately. And for example, one of the things that at times a lot of students don't know is that if the mark scheme has a method mark and then has an answer mark, let's say it looks like this, M1 and A1. Now, if you lose the method mark, you automatically lose the answer mark as well, even if your answer is correct. And that's pretty logical. What it's saying is that if you're using a wrong method, then you don't deserve credit for it. You can either score both of these, so you can get 2 out of 2, or you can get 0 out of 2. You cannot score 1 out of 2 when there's an answer mark that is being, or a method mark followed by an answer mark. Now, in the case where it says B1 and B1, B is an independent mark. It means you could get this wrong, get this right, or you could get this right and get that wrong, or you could get both right, or you could get both wrong. Over here, you can score 0, you can score 1, you can also score 2. And then C is actually a compensation mark. Most of the times it's just given for using the correct equation. And it carries a mark if you know the equation and you write it down, you get the mark for it. And another thing, for example, good test taking habits, for instance, if we just look at this equation that we used earlier, now some people will not write this out. What they will do is they'll say P is equal to whatever the density is, put the value of G, and put the value of height, and then just go on and give the result. That is okay, but it's very strongly recommended that you do not do this. Always write out the equation first. It will help you avoid mistakes and also makes life easier for the examiner, actually. So in other words, you only gain from it, you don't lose anything. So always write out the equation. Okay, so by the way, are you familiar with the OctiLearn app? Have you guys checked it out?
I did.
Okay, what do you think about it?
It's good, but I've never really like used it because like I get lost on what to use.
Can you explain what you mean by that? Because basically we have
I did
obviously,
use it for physics for the chapter 6, and I did like it.
okay, and have you
For the
used the AI
question.
tutor?
No.
I'm sorry, what is this? Is it like a website?
Yeah. So if you go to OctiLearn.com and you can just, or if you just directly go to the app link, it's app.octilearn.com. You can just create an account and start using it. We're actually a startup, so we're always making improvements. And that's why I'm asking you, you know, how it's been. So for instance, if you go in to, let's say we go into any of these, then here's the syllabus. So, you know, you can mark what you've done and what's left, and it tracks your learning objectives. So how many, and if, for example, let's say you're having trouble with this, you can also add a comment here just so that you remember, and then you can, you know, track what it is that you're having trouble with. When you add a comment, it basically gets added, and you can find out, if you click on it, you'd be able to read your comments. And we have notes. So let's say I go into motion. The motion is divided into these subtopics. We actually call it a snack. And then each snack, for example, subtopic, is broken into these sections. So if you click on definitions, it only shows you the definitions, for instance. And then if you click on equations, key concepts, you can also use filters. So for example, if I do common misconceptions, then it's only going to show me the common misconceptions in each of these subtopics. And you see there are some common misconceptions that students have, and then they're responded to. Then what you can actually also do is if you click this, copy to my library, and you say, yes, I want to save it, and you go to my library, it creates a copy of our content in your own library. And you can then go in and edit our content. So let's say you have this. If you click here and do edit, you can actually go in and change our content. So let's say, you know, this is really basic stuff. So I'm sure you're pretty comfortable with it. You can just do that, delete it, and hit save. And once you save it, it means that your version is now going to be different from our version. So that means every student can have a unique version. If you go to OctiLearn library, you would see our content. If you go to my library, you would see your own content. And then we have flashcards on the syllabus. And then if you go to assessments, these are the past exam questions. So you can select a topic. For example, if I go here, you see it's saying 73 questions from these years. If I want to do questions on a specific subtopic, let's say acceleration, then I can go into that and it'll only show me questions on acceleration. When you go to analytics, it gives you a detailed view of your scores. So for example, over here, it's going to show you, you know, your best to worst ranking. So it ranks all of the subtopics inside motion to tell you which ones you're doing better at and which ones you need to focus more on. This is, the table is showing you the stats for motion. If you expand the breakdown, again, you see it's going to tell you for each subtopic what your percentages are. And then in the simulations tab for physics, chemistry, and biology, we have interactive simulations and 3D models that you can use. Again, the idea is to help you visualize what you're learning. So for example, in this one, you can go in and do these activities. With the AI tutor, for example, let's say, for example, I think Jonna had a question. We've trained the AI tutor according to the syllabus. So I'm just going to say, explain the equation P is equal to rho G H. Why do we, so for example, why do we use delta in that equation? Yeah, there you go. Delta P represents the change in pressure between the two different depths. Delta H is the change in height between the 2 points. And it's saying that we use the delta symbol when we're interested in the difference in pressure between 2 points at different depths rather than the absolute pressure at a single depth. And you could then say, create 5 MCQs on that to test me. And I'll say, don't give the answers until I ask. So you see that it can generate questions, you can attempt, it can explain. So basically, it can really help you revise a lot quicker. You can also say, help me revise pressure, or give me the key points of pressure. Or if you have misconceptions, you can get it addressed. And as we go on, what we're actually going to do is, I think in a couple of weeks, we should be able to do that. That when you go into questions and you need some help, you would be able to ask the AI tutor to help you out. Right now, we haven't done that, but that's the next thing we're going to do. So for example, if you go into questions and you're stuck on a question, just to give an example, you're here on the screen, you don't know how to do this one, you'll see an icon where you'll say, help me with this, and it will basically explain the question to you. So, we're always basically, and then next thing we'll do is add video content to the app to just complete the ecosystem.